Welcome to Good News and Chill. Positive news to relax or fall asleep. Because a lot of things suck, but not everything. Our first story is from today.com. A new baby tortoise at the Denver Zoo officially has a new name. The baby African pancake tortoise's birth was announced on June 10th. The zoo then turned to today.com readers to select the perfect name for the baby girl, and Maple was the clear winner. The female reptile is the first of its species to hatch at the Denver Zoo, which is also home to her mom, Waffles, and 3 male tortoises, Shortstack, Denny, and Flapjack. Here's why Maple's arrival is exciting for the zoo and her species. Holly Hauser, Assistant Curator of Animal Ambassadors at the Denver Zoo, tells Today that while the zoo was not preventing natural breeding behavior between its 3 males and female, they were still surprised when Waffles laid a perfect egg that was discovered last December. It's one of those things that we weren't necessarily expecting, but for a critically endangered species, we definitely welcomed it, Hauser says. The zoo incubated the egg to see what happened, Hauser explains. And after around 6 months of waiting, a perfect little tortoise hatched on May 23rd. The tiny tortoise will soon have a big role at the zoo as an animal ambassador. Maple will meet thousands of visitors at the zoo each year to spread awareness of African pancake tortoises and other endangered animals from East Africa, where her species is from. Our whole mission is to protect animals and save animals in the wild, Hauser says. So, this tortoise will actually have a pretty unique role at the Denver Zoo. While the baby reptile has already started training with animal handlers, Hauser says making sure she's eating well and thriving takes priority. And so far, so good. It's really cute to see her try to bite a big berry and a big piece of lettuce, Hauser says. But she's very voracious. She is super healthy. The Denver Zoo asked for help from today.com readers to pick a pancake-themed name for its new baby African pancake tortoise. A naming tradition that Hauser says is a fun, interpretive element that helps build connection between people and the animals. The baby tortoise might not be the newest member of the clan for long. As Hauser says, Waffles laid another egg in February. Next, from Science News on June 23rd. scientists have successfully modified bacteria to convert plastic waste into acetaminophen. Dealing with plastic waste is a real headache. But with a little help, bacteria can turn plastic into a painkiller. Genetically engineered E. coli bacteria converted a broken down plastic bottle into the active ingredient in pain medicines like Tylenol and Panadol. The approach could help reduce plastic pollution and curb reliance on the fossil fuels now used to make the ubiquitous medication. I genuinely think this is quite an exciting sort of starting point for plastic waste upcycling, says Stephen Wallace, an engineering biologist at the University of Edinburgh. Plastic waste has long been known to harm the environment and human health. But scientists like Wallace are turning to microbes to convert plastics into more useful and valuable products. Combining biological processes with chemical reactions that don't usually occur inside cells makes nature do chemistry that it's never evolved to do before, Wallace says. His team made E. coli do just that. Before setting the bacteria to work on manufacturing pharmaceuticals, the researchers backed up a step and tested the microbe's ability to create a necessary precursor molecule called para-aminobenzoic acid, or PABA, from plastic. And key to that step was seeing if E. coli can support an essential chemical reaction called a Lawson rearrangement, which alters the structure of a nitrogen-bearing molecule to make PABA. The scientists modified E. coli so that it couldn't make PABA through its regular biological pathway. That way, the cells would die without getting PABA, which is also essential in making the vitamin folic acid through another route. They then gave those bacteria a starting compound that turns into PABA only after going through a Lawson rearrangement. The cells lived, a clear sign that the Lawson rearrangement was taking place. Next, the researchers prepared the same starting compound by chemically breaking down a plastic bottle ingredient known as polyethylene terephthalate. Again, the E. coli thrived, turning the plastic-based precursor into PABA. Turning plastic waste into fuel for organisms is interesting in its own right, Wallace says. But he and his colleagues took the reaction a step further. With some additional genetic instructions, E. coli can convert PABA into paracetamol, also known as acetaminophen, the active ingredient in the painkillers Tylenol, Calpol, and Panadol. The tweaked E. coli converted 92% of the broken down plastic waste to paracetamol within 48 hours. Most paracetamol is currently manufactured from fossil fuels, so the new process could someday offer a more sustainable route to preparing the medicine, Wallace says. There's a long way to go before this process could be scaled up. The method the researchers used to break down the plastic bottle would be difficult to scale to industrial proportions, says Dylan Domale, a chemist at the Colorado School of Mines in Golden, who was not involved in the new study, but demonstrating that bacteria can turn plastic waste into something useful could motivate efforts to make breaking down plastics more scalable and sustainable, he says. A long-term goal might be to get one or more types of microorganisms to perform every step of the transformation, says Venkatesh Balan, a biotechnologist at the University of Houston, who also was not involved in the study. Designing a single organism that can both break down plastic directly and turn it into useful materials is challenging, he says. But this fundamental study will be a stepping stone in the right direction. From Brighter Side News, scientists solve centuries-old mystery. Have you ever wondered what makes an old Italian violin sound so special? For centuries, musicians and scientists have puzzled over the unique qualities of instruments made by masters like Antonio Stradivari and Giuseppe Guarneri. These violins, crafted in Cremona, Italy, hundreds of years ago, are still preferred by top performers today. Even with all our modern advancements, we still haven't quite figured out how to replicate their amazing sound. For over 200 years, experts have debated why Cremonese violins are so unique. Some blind listening tests, where people can switch between recordings, have favored Stradivari violins. However, other tests with live performances haven't always shown the same clear preference. This ongoing debate highlights how complex the sound of these instruments truly is. Many have suggested that the Cremonese masters used secret techniques now lost to create their masterpieces. Scientists have mostly looked at the shape and varnish of these violins, but simply copying these features hasn't been enough to reproduce their special playing qualities. The soundboard of a violin is its most important part for making a sound. It also has to be incredibly strong to handle the tension from the strings, which can be around 8 kilograms of force. Modern violin makers usually copy the shapes of Stradivari and Guarneri soundboards, but they often make them thicker. A typical modern soundboard is about 3 millimeters thick, or even up to 3.5 millimeters. In contrast, Stradivarius soundboards were usually between 2 and 2.8 millimeters thick, and Guarneri's were 2.2 to 2.9 millimeters. While some older soundboards might have been thinned later, their combination of thinness and durability points to special material properties. This suggests that the unique qualities of these violins weren't just due to the type of wood or how it was chosen. Spruce and maple, the woods used, are still common in Europe. Also, CT scans show that the density of these woods is similar in old Cremonese and modern instruments. This led researchers to believe that the distinctive properties came from some kind of artificial treatment. These samples included both spruce and maple from the major Cremonese violin-making families, Amati, Stradivari, and Guarneri. They compared these samples to modern violin woods, as well as aged wood from ordinary old violins and even ancient Chinese instruments. The research confirmed a long-held theory by Joseph Najvari, Professor Emeritus of Biochemistry at Texas A&M University. About 40 years ago, Najvari first proposed that chemicals used to treat the wood, not just the craftsmanship, were key to the violin's unique sound. He believed this was partly due to widespread worm infestations at the time, which would have threatened the wood. All of my research over many years has been based on the assumption that the wood of the great masters underwent an aggressive chemical treatment, and this had a direct role in creating the great sound of the Stradivari and the Guarneri, Najvari stated. His initial findings were even verified by the American Chemical Society. The current research supports Najvari's theory, identifying several chemicals used to treat the wood. These include borax, zinc, copper, alum, and lime water. Najvari notes that borax has a long history as a preservative, going back to the ancient Egyptians, who used it in mummification and later as an insecticide. The presence of these chemicals suggests a collaboration between violin makers and local pharmacists. Both Stradivari and Guarneri likely wanted to protect their precious wood from worms. Najvari believes that each violin maker probably had their own special methods. This new study reveals that Stradivari and Guarneri had their own individual proprietary method of wood processing, to which they could have attributed a considerable significance, he explained. He thinks they realized that the special salts they used also made the wood stronger and improved its sound. These methods were kept secret, as there were no patents back then. You couldn't guess how the wood was treated just by looking at the finished violin. Najvari also points out that varnish recipes were not secret because varnish doesn't significantly affect the tone quality. However, the process of treating fresh spruce planks with water-based chemicals was crucial for the final sound. This knowledge gave them a competitive edge over other instrument makers. The team found these chemicals were not just on the surface, but all through the wood, directly impacting its sound quality. Antonio Stradivari made about 1,200 violins during his lifetime, selling them to the very wealthy. Around 600 Stradivari violins still exist today. Guarneri, a less famous contemporary, struggled to sell his instruments, and yet today his violins are considered just as good and often as valuable as Stradivarius. Their violins have been unmatched in sound and quality for 220 years, Najvari observes. A Stradivari violin can be worth $10 million, and a Guarneri can be worth even more. Further research is needed to fully understand how these chemicals and the wood created such pristine tonal quality. Najvari emphasizes the need for more samples from the golden period of Cremona, 1660 to 1750. He also calls for better cooperation between antique instrument restorers, modern violin makers, and scientists. Najvari himself has spent much of his 87 years researching violins, having even learned to play on an instrument that once belonged to Albert Einstein. The secrets of the Cremonese masters are slowly being unveiled, showing that their artistry extended beyond craftsmanship to a sophisticated understanding of materials science. And speaking of music, singing or playing music throughout life is linked with better brain health while you age. An article from the Good News Network last year. Playing a musical instrument has obvious rewards. The sense of fun and enjoyment, the ability to express feelings in different ways, and the satisfaction experienced as proficiency improves. But could it actually be making you smarter? Scientists working on Protect, an online study open to people aged 40 and over, reviewed data from more than 1,000 adults to see the effect of playing a musical instrument or singing on brain health. And what they found was that apart from any benefits it has for emotional well-being, it actually improved the memory and cognitive speed of the 40 and ups. Over 25,000 people have signed up for the Protect study, which has been running for 10 years. And in order to come up with this exciting finding, the team reviewed participants' musical experience and lifetime exposure to music, alongside results of cognitive testing to determine whether musicality helps to keep the brain sharp later in life. The findings show that playing a musical instrument, particularly the piano, is linked to improved memory and the ability to solve complex tasks, known as executive function. Continuing to play into later life provides even greater benefit. The work suggests that singing was also linked to better brain health, although this may also be due to the social factors of being part of a choir or group. A number of studies have looked at the effect of music on brain health. Our Protect study has given us a unique opportunity to explore the relationship between cognitive performance and music in a large cohort of older adults, said Anne Corbett, professor of dementia research at the University of Exeter. Overall, we think that being musical could be a way of harnessing the brain's agility and resilience, known as cognitive reserve. Although more research is needed to investigate this relationship, our findings indicate that promoting musical education would be a valuable part of public health initiatives to promote a protective lifestyle for brain health, as would encouraging older adults to return to music later in life, she said in conclusion. There is considerable evidence for the benefit of group music activities for individuals with dementia, and this approach could be extended as part of a healthy aging package for older adults to enable them to proactively reduce their risk and to promote brain health. Stuart Douglas, a 78-year-old accordion player from Cornwall, has played the instrument throughout his life and now plays with the Cobar Valley Accordion Band, as well as the Cornish division of the Royal Scottish Country Dance Society. I learned to play the accordion as a boy living in a mining village, and I carried on throughout my career in the police force and beyond, said Mr. Douglas. These days, I still play regularly, and playing in the band also keeps my calendar full, as we often perform in public. We regularly play at memory cafes, so I've seen the effect that our music has on people with memory loss. And as older musicians ourselves, we have no doubt that continuing with music into older age has played an important role in keeping our brains healthy, he added. The idea for the study came from University of Exeter Medicine student Gaia Viteri, a keen pianist who contacted the Protect study team. As a pianist, she said, I was interested in researching the impact of music and cognition. Being fairly new to the world of research and publishing, this was a challenging but also a truly enriching experience. If you're enjoying good news and chill, we'd sure appreciate it if you like and subscribe, or even recommend us to a friend. We'll be back next week with more good news.